Hi, I'm Evia. Today I'm going to talking about my project, compression and accuracy of neural network in communication system. First of all, let me introduce you what is the neural network. This picture is the neuron structure of human. The human visual system can easily recognize the numbers and characters in the picture. In order to make computers recognize, scientists create computer neural networks by imitating the structure of the human neurons. Before we understand neural networks, we need to know what perceptron is. Perceptron is a binary classifier, which is the foundation of the neural network. In short, it's a simulation of nerve cells with weight, bias, and activation functions. The input represents x equal to x0, x1, and x2 as a vector. You can think of them as different feature dimensions, where x0 is the bias unit, which is equal to the constant term in linear regression. After the calculation of neuron, the perception will output a number greater than or less than 0. The number on the arrow represents the weight of each feature, which is equivalent to a parameter of the linear regression model. It's a synapse that corrects information. Suppose we have a model hx equal to minus 3 plus 2x1 plus 2x2. When x1 and x2 are equal to 1 at the same time, the output is 1, and if they are different, they will get negative numbers. This is actually logical and all called AND gate. Our perception will classify the input according to the output greater or less than 0. This is a single-layer perception. By modifying the weight, we can also create OR gates. Weight is 2, 2, base is minus 1. Non-gates, weight is minus 2, base is 1. However, in any case, you cannot build XOR through a single layer perception. That is, two inputs output 1 at the same time, otherwise output 0. In this case, we need a more complicated neural network, that is, multilayer neural network, also known as feed-forward neural network. Feed-forward neural network is a combination of multiple perceptions which are connected in different ways and activated by different activation functions. As we can see in this figure, a neural network can represent as a graph. A node means a unit, and an arc means a link. A neural network is included input layer, output layer, and one or more hidden layers. The neural network in the figure above is composed of input layer of 6 units, hidden layer of 4 units, and output layer of 2 units. Units equals to perceptions. The input layer unit is the input of the hidden layer unit, and the output of the hidden layer unit is the input of the output layer unit. The connection between two perceptions has a weight, and each sinner in layer T is related to each sinner in layer T minus 1. Of course, you can also set the weight to 0 to actually cancel the connection. When processing the input data, you give the input data to each unit of the input layer, while each unit of the hidden layer is the weighted sum of each unit of the input layer. In other words, the data of the input layer will be progressed forward to each unit of the hidden layer. In the same way, The output of the hidden layer propagates forward to the input layer as the input, and the final output, that is, the output of the neural network, is calculated. And the neural networks of multiple hidden layers have the same principle. In order to make the neural network achieve the goal we set, we need to train the neural networks. Backpropagation is an algorithm that uses data to train neural network. It's a gradient descent algorithm to neural network. Suppose we have a training set, which contains the input vector and the corresponding target output vector. At the same time, if our network already has a set of weights, then we need to use the following algorithm to adjust these weights. Firstly, using the initial weight, the forward propagation is performed on the input vector, and the output of all the neurons in the network is obtained. Secondly, in this way, each output layer neuron will get an error, that is, the difference between the output value and the actual value. Secondly, the gradient of the error as a function of the neuron weight is calculated, and then the weight is adjusted according to the direction of the fast error reduction. Thirdly, these output errors are propagated back to the hidden layer to calculate the corresponding errors. Lastly, the gradient of these errors is calculated, and the weight of the hidden layer is adjusted in the same way. This method is used to iterate until the network converges. In this way, the training progress of neural network is over. Because a neural network is very complex, when it is used in communication network, we wanted to occupy smaller memory and faster speed, so we need to compress and accurate it. In my project, I applied the low-rank method for compression. In convolution neural network, convolution is performed by matrix multiplication. For complex networks, the weight matrix is often large, which takes up storage and computing resources. Low-rank approximation is to combine several low-rank matrices and reconstruct a high-weight matrix to reduce the consumption of storage and computing resources. In my project, I used a 128 phase training sets to train the neural network, which means to make the neural network use non-figure points on each face to judge whether the face is happy or not. Features extracted from the 128 face image provided in the M by N matrix X in the file face emotion data.mat. This file also includes the labels Y. Here, happy faces are labeled 1 and unhappy faces are labeled -1. I need to find the Y's for a linear classifier that will use the features to predict whether the emotion displayed on a face image is happy or unhappy. Define a feature vector xi and a classifier weight w, so we can get the basis formula for the label. Yi is equal to t squared xi w. Here is the code. I write it in Python. Firstly, we extract the data from the file and store it in a matrix. Then, we calculate the weight. In this step, select the value of weight that has a great influence on the result. Finally, we calculate the accuracy rate, and the result after using low rank was not much different from that after not using it. Thus, With this compression method, the calculation quantity of the matrix becomes smaller, and the accurate rate does not change much. Thanks for watching. Do you have any questions?